Hey guys, here we all are back on the same page. Everybody should be doing this particular lesson, even though the AP exam is over, and ordinarily we would be going to Six Flags and we would just be chilling like a villain. Bummer. Plus, I know you're still taking AP exams. So I'm sorry that this is overlapping with that, but I will do my best to make this available throughout the summer so that if whatever happens, happens and you can still survive. Okay, so we're going to graph these polar coordinates. I believe that what I'm about to do is review for you. So, I don't know if you remember this, but what you theoretically remember from, what is it called? What's that class called? I don't remember anymore, y'all. I'm so tired. I'm so tired. Okay. It's called pre-cal. That's what it's called. Okay. So what you might remember from pre-cal. Oh, that's terrible. I'll try that again. What you might remember from pre-cal. Why isn't that being a circle? Is that first circle there is radius 1. So what we do here is we go out to radius 4. 1, 2, 3, 4. But we're not at pi over 2. We're at 2 pi over 3. Boop. There's our little... Oh, my cat wants in. Y'all, my cat is being really weird because it rained really hard and she can't figure out what's happening. Okay. I can't draw either because my marker isn't working. I'm sorry. 1, 2, 3, 4. I think I can count. There, it finally worked. Okay, I need to pause. Poor little Nancy Drew does not understand why the pavement is wet. Poor girl. The life of a cat. Okay, so. Oh, I can actually move the whole dot. Okay, that was kind of interesting. 3, 7 pi over 6. So most of us, let's get real, go over to the angle first, and then we figure out where it is. So 7 pi over 6 is over here. Boom, boom. And we go out 1, 2, 3. And if your marker works, you make a dot. Then we go over to 5 pi over 4. 5 pi over 4. Uh-oh, it's not on there. Well, over here is 3 pi over 4. I don't know why my marker's not working quite right. Just pretend. Pi 3 there. There's 5 pi over 4 over here. And we need to go out negative 2. So instead of going out 2, which would be here, we go out negative 2, which is in the opposite direction. Right there. Now, I'm kind of going through this quickly because I'm pretty sure you learned this last year. If you didn't, I apologize. And, oh my gosh, my cat is being so psycho. Okay, we go, for the last one, for D, we go out 2 again, but we go to negative pi over 6. And negative pi over 6 is actually down here in case you forgot. But again, I'm pretty sure for almost all of you, this is review. So 2 negative pi over 6. I'm trying really hard not to waste your time. Oh my gosh, my pen. Help. I don't understand why it's not running today. I'm going to keep this all in because I know you miss my weird sense of humor. Oh my gosh, this is so weird. What is happening? Life, life, life. No. There. Okay. Okay, so we got all our dots graphed. Hopefully that was easy for you. In pre-cal, hopefully, you learned that oh yeah, this was on our green sheet, so I'm going to throw this up here real quick. Okay, so cosine of theta is x over r, sine of theta is y over r, tangent of theta is y over x, x equals r cosine theta, y equals r sine theta, x squared plus y squared equals r squared, and r equals the square root of x squared plus y squared. This right here, this x squared plus y squared equals r squared, is the same thing as saying r cosine theta all squared times r sine theta all squared equals r squared. So you see in there the Pythagorean theorem or the Pythagorean identity, sine squared plus cosine squared equals 1. So I broke it down. So if you didn't see it before, you should be able to see it now that cosine squared theta plus sine squared theta is right in there as 1. Okie dokie. So I don't know what the graph is for there, by the way. I've never been able to figure that out. So we're going to convert 2 comma 5 pi over 6 into rectangular coordinates. So we go ahead and pull down our equations for x and y, substitute in our values for theta and r, and very easily we get our xy coordinates. And theoretically, this is something you saw last year. There are some that are more difficult than others. This was one of the easier ones. There are a few that you're going to bump into in your assignment. They're going to be rough. Now we're going to convert the xy coordinates 3, -3 to polar coordinates. Okay, so we go ahead and solve for r. We could either solve for x or y to find theta, and we found our r value and our theta value with very little trouble. And I believe this is the sort of thing you did last year. Not really sure. But we're about to pop into stuff that you have not seen. So hopefully you're still relatively comfortable with this. If you have questions, please let me know. Sorry, I'm not sure. Oh, there we go. Okay. We are going to convert the following equations to polar form. And if you look at A, that is a line. Dun, dun, dun. And because it's a line, there's not much we can do there. We can replace y with 4, which I have done. I have replaced y with 4. I moved it, but I have kept the mathematics correct and solved for r. We have a number of different thetas there. All we have there is an equation. Just like in A, we just have the equation of a line. For cosecant theta, if you're to graph that on your calculator, you're going to end up with a straight line. On this next one, you should see almost immediately that this is the graph of a circle. If this is the graph of the circle, then we know what r squared is. R squared is 25, which means that r is in fact 5, and that describes the entire graph. You don't need to know anything more. We are going to now convert the following equations into rectangular form and sketch the graph. Oops, the graphs are off the page. Well, we'll just, let me see. Doop. Oh, oops, I split it. Oh, no, I didn't. Okay. We're going to graph them below. Yay! I'm smarter than I think. Our sine of theta is this is just y. So we have a line y equals 3. Easy peasy. On this next one, r equals 2 cosine of theta. Well, that right there is describing x. So we have a line x equals 2. Haha, that was a blonde moment. So not really. We need to solve using our whatever they're called, these things over here, our formula. And when we do that, we see that we can use this relationship of r squared. All I did was multiply both sides of this equation by r to get that next step. And once you do that, then things start to fall into place pretty easily, because embedded in this right here is in fact x. So r squared equals 2x. From there, we can see that we have a relationship here. Oops, that really didn't turn out very pretty. We have a relationship here where r squared is defined in two different ways looking at the rectangular representations of it. And there we get our ellipse. And that is what it actually creates, not a line. Moving onward to C. Oops, blonde moment again. I need to graph it. And that's not an ellipse, it's a circle. Ha! Sorry. I really am not very awake. Okay, last thing. I hope that you can see right away that that is in fact a line. And I hope that you can see right away the slope of that line and all of that jazz. In my head, I personally go back to rise over run, and I find that your slope will be the square root of 3, your y-intercept will be 0, and there your line is y equals, oops, I forgot the negative. Y equals the negative square root of 3 over negative square root of 3x. Boom. That's all there is to it. Next one. I didn't leave myself enough room, but you have enough room in your book, so. And in general, on any given year, this would have been, except for this year, this would have been fair game on the AP exam, which is unimportant in and of itself. What is important is that you will be expected to know this. Your college professor will expect you to know this. They will expect you to understand that the slope of the tangent line to a polar graph at any point can be found using this particular formula. I believe, if I'm correct, oh gosh, I hope I'm correct, this should be in your BC formula packet. If it is not, or you need a copy of that at any point in college, please let me know. Okay, last problem of this section. Find dy dx and the slope of the graph of the polar curve at the given value of theta. So you're going to use that formula on the previous sheet. Oh, and no, you're not. You're gonna go ahead and differentiate this whole little stinker, and then you're going to calculate that out at the given value of theta. And yes, you are going to use the formula. I'm sorry. It's like 10:30 and you guys took your AP exam today, and I'm tired because the whole time you were taking it, I was having a nervous breakdown. And it's really hard to get motivated anymore because I haven't seen your lovely faces in forever. Okay, so 3 plus 2 sine of theta times the cosine of theta. I'm going to finish this. Go ahead and calculate that out at pi over 6. And I'm going to go ahead and simplify it. If this were the actual AP exam, you could leave it that way. However, you have taken the AP exam or you have not, and you're going to be dealing with some stodgy college professor. I say that. They're not all stodgy. They will expect you to simplify this in college, so I'm going to go through that process quickly. Okay, now using all of my values, we end up with, oops, I got to make this bigger, 2 square root of 3 plus the square root of 3 over 2 all over negative 2 plus 3/2, which is actually going to give us a relatively pretty number. -5 square root of 3. And y'all, that's all I can do this Tuesday, May 12th. I hope that you are doing well, and I hope that you're able to power through this. Tomorrow I'm going to put together another video to add to this. It will be on finding the area in a polar curve. And invariably, this is the section that my students struggle with the most. So I'll put that together for you, and hopefully it will be up sometime. I'd like to see it up by noon, but honestly, I don't think so, because I have a bunch of parent Zoom meetings to go through. So I will put it up as soon as I am able to help you get through the rest of this, the curriculum. Okay? Take care of yourselves. Good luck on the rest of your AP exams. Bye.